Hello everyone. Write down continuity theorem. Continuity. What is continuity? Look here. It's a pipe with the different cross-sectional areas at both ends. This, let's call it A1. Cross-sectional area is A1. And on this side, cross-sectional area is what? A2. A1, A2. And a liquid is present and is flowing through the pipe. And when liquid is flowing through this, we found that at this cross section, velocity of the liquid is v1. And at this cross section, velocity is v2. This continuity theorem is going to relate a1 v1 with a2 v2. And what basically it is, you will understand when I produce all the steps in it. So, right now, the setup which you are looking at, let's say, is drawn when time was 0. This figure which you see is at t equals to 0. The whole setup. And remember, in this setup, the space which looks empty, remember, is filled with water or any liquid, and that liquid is flowing with V1 at this cross section and is flowing with V2 at this cross section. This is at t equals 0. At time t, we found that this portion has reached this place. And the front portion is somewhere here. The thing which you see in blue is at time t. Let's call it like this: A, B, C, D. At t equals to 0, you're looking at A, B, C, D, this portion. Whereas at time t, you're looking at A dash, B dash, C dash and D dash. That time t we are looking at this A dash, B dash, C dash and D dash. When time is 0, you're looking at this volume. And when time is t, you're looking at this volume. I hope you can see different colors. If you cannot, then in A, B, C, D, use one color, and in A dash, B dash, C dash, D dash, use a different color. I hope it's much more clear now. So, what happens? You have a tube with cross-sectional area A1 and cross-sectional area A2 at different ends, and a liquid is flowing through the tube. Just imagine this is a liquid, and this liquid is passing through a tube. As it passes through, at time t it looks like this. After some time, we are drawing the second figure in which this cross section has moved to this position and this cross section has moved and occupied this new position. I hope this figure and all everything is clear. Now, whenever we talk about fluid mechanics, there is a requirement which should be fulfilled by all the liquids. And that requirement is your fluid should be incompressible. Incompressible means if instead of this marker I run a spring along the length, then what I can do is, if I say that 10 turns of that spring goes inside, it's not necessary that 10 turns will come out. Depending on the compression which I keep in my hand will give you the number of turns that are coming out. But if things are incompressible, you cannot compress the thing, you cannot change its density, which we are using in this particular setup, then as you push the liquid and it comes out, we can say that mass in A, B, C, D is same as mass in A dash, B dash, C dash, D dash. This statement is coming because of this logic that liquid we are dealing with is incompressible. If this black portion becomes blue, black becomes blue, we are saying that mass is what? Same. If mass is same, then it also tells us what? Mass in A dash, D dash, D. What is this? A dash, D dash, D is same as mass in B dash, C dash, C. B dash, C dash, and C. You need to understand this part. This is the thing which is important and is all about continuity theorem. But first do one thing, draw everything and write down this, and I'll explain again logic behind this part. Before that, note down everything, draw this figure at t equals to 0 and at time t using different colors. Note down this much. Now try to understand the meaning of incompressibility and everything. There is some liquid behind this black portion which is pushing it in, and similarly there will be some liquid in front of this black portion. It's a continuous flow of water or any liquid through a pipe, and we are looking at an imaginary volume A, B, C, D. This is the imaginary volume. This is that imaginary volume. Out of the whole liquid column, we are interested in a portion shown in black. Remember, there is some liquid behind which is pushing it in, and similarly there is some liquid in front of it which is being pushed by the black portion. At t equals to 0, you're looking at A, B, C, D. At time t, this black portion, this cross section is over here, and this one is over here. Now, regardless of compressibility, mass in A, B, C, D will be same as in A dash, D dash, C dash, D dash, provided you say that this thing reaches this position and this thing reaches this position. This much has nothing to do with compressibility and all. You have a spring of, let's say, 1 kg and you hold it in this much volume. You compress it, mass is still what? Same. That is not going to change. So, as far as this portion moves this portion moves and occupies this position. If we are saying that all the liquid could not leak through the walls, then this statement is always correct, always. But for this second statement, if you are saying that this mass is same as this mass, then you need to make sure that the common portion, I will show the common portion with red color. This thing in red from A dash, D dash to B, C. This much portion in red, if you say liquid is completely incompressible, then we are assuming that all the mass and therefore volume of this portion remains same because of the incompressibility. That means this mass and this mass, they are of same value. Things are easy and you will be wondering that why am I stressing on the part incompressible and all. Look here. Just imagine a cylinder like this, and then you compress it from this side and it takes this shape. I hope you can see that I've drawn different lengths. These are different lengths. Let me draw it again so that you can easily see the change in length. It's a cylinder, assume made of sponge, which you can easily compress. What you did, you moved this end this much. And cross-sectional area is same throughout, remember. What we have done, we have compressed this end from this position to this position. And this end moves from this position to this position. Look at different displacements. This is of sponge. Remember, something which you can easily compress. Now, mass of the black one and mass of the blue one, I hope you understand that they are same. You have a cylinder of sponge, you compress it. If you compress it, it doesn't change its mass. So from black, when you move to blue, you're saying that they still have what? Same mass regardless of compressibility factor. This part. But if I say that this much portion and this portion in blue, this and this, black and blue, the common portion, this was present before and is also after you let it through this pipe. If these portions are not incompressible, then this mass and this mass, they will not be same. If and only if you say the entire liquid is incompressible, that means mass present in this common portion shown in red, if you have a liquid which is completely incompressible, then this common portion will share same amount of water molecules, and we can say that this portion and this portion, they are of equal mass. Let's understand this with the help of this figure again. Last attempt. Look here. Suppose we have a spring like this, and these are the number of turns. If I move it and I do something like this, 1, 2, 3, 4, 1, 2, 3, 4. In the common portion, I hope you can see that density of blue one is greater than the density of the black one. The black one, when you compress it, this end moves and occupies this position, this end moves and occupies this position, but since it's a string which can be compressed, in the common portion you can see that there are different number of turns. And if there are different number of turns in terms of water or any liquid, we are saying that there are different number of molecules present. In this scenario, it is not correct to say that this amount, this much water, mass of this water and mass of this water, they are same. For example, number of turns present between this 1, 2, 3 and this 1, are they same? No. When will they be same? Provided you cannot compress this thing, common portion holds same number of turns, or in this case, same number of molecules. Let me ask you, do you understand meaning of incompressibility and why is it a must if you want to have mass in this portion and in this portion to be same? If you understand this part, write down yes in the comment box. Well, this is the basic idea behind continuity theorem. Good. If you wish, you can also draw this and this as a side note so that you understand what all is happening. Write down a statement. If liquid is incompressible, then number of molecules present in present in common portion A dash, B, C, D dash will remain same at t equals to 0 as well as at t equals to t. T equals to t means when time is t. Which means we can say that all the mass present in A dash, D dash D is same as that present in B, B dash, C dash, C. B, B dash, C dash, C. In fact, एक तरह से आप क्या बोल सकते हो? आप बोल सकते हो कि आपने ये जो कॉमन पोर्शन है इसको कुछ किया ही नहीं, आपने यहां से ये ब्लैक पोर्शन इतना कट किया और उसको उठाकर यहां पर फिट कर दिया. प्रोवाइडेड liquid is incompressible. All the molecules present in common portion, they are same because liquid is incompressible. When you are moving it, density is not changing. So all the molecules which were present earlier at t0, they are still present at time t. तो हमने क्या बोला, जब ये पोर्शन कोई चेंज ही नहीं है तो फिर सिंपलिसिटी के लिए क्या बोल दो, ये पोर्शन इसको कट करो, उठाकर यहां फिट कर दो. वंस यू से कि आपने ये कट करके यहां फिट किया हुआ है, इट immediately gives you what? Mass is same. This incompressibility gives you an idea of this mass and this mass. Now, once you say mass, let's find out this mass. Speed at this cross section is v1. From black, when you arrive at blue, time is t. And therefore, this distance will be v1 multiplied by t. From this position to this position, displacement will be what? Velocity multiplied by time. Which means, what is this? Velocity at this point is v2 multiplied by t. Now, I have the length. If I have the length, then I can find easily the volume. Multiply with density and you get what? Mass. So what is mass in A dash, D dash, D? Length multiplied by cross-sectional area A1 into density rho, volume multiplied by density. What is mass in this portion? Volume, which is length into cross-sectional area. V2T multiplied by cross-sectional area A2 multiplied by density rho. T rho cancelled, and what is the relation between A1 V1 and A2 V2? Relation is A1 V1 is equal to A2 V2, which is known as continuity theorem. It works provided you have an incompressible continuous liquid. Note down this much, and if you understand the derivation completely, then write down yes in the comment box. And if you have any doubt, then mention your doubt. Good. Now, it may look that we are relating this cross section with this. In fact, what we have done, we have proved that just under this you can write like this. Continuity theorem says that product of cross-sectional area and velocity at that cross-section is always a constant. Write down the final statement now. According to continuity theorem, for an incompressible liquid, according to continuity theorem, for an incompressible liquid, product of cross-sectional area and velocity at that cross-section is constant everywhere. So it's not at this and this, it's at this cross-section, at this cross-section, at this cross-section. If you have a pipe with variable cross-section throughout, continuously changing cross-section, you can always use what? Product of A and V constant, provided you have incompressible liquid. Now, this is something which is you have already experienced in your life. If you're holding a pipe and you when you're watering plants, and if you simply cover half of the cross section of the pipe, so as you reduce the cross section, you have seen that speed increases. It's coming from this. If somebody tries to decrease A to keep the product constant, V will increase. So the moment you cover or decrease the cross-sectional area of the pipe, you find that speed has increased. Now let's try to answer a few questions on the basis of this. Write down the question. If cross-sectional area of a pipe is decreased and made half, then find out change in the range, if pipe is held at an angle of theta. I hope you understand what the question is. We have a pipe and its cross-sectional area is halved from A. You made it A by 2. The pipe was held at an angle of theta. Pipe is held at an angle of theta, and then you halve the area, cross-sectional area. Then what happens to range? Let's see how many of you answer this. And you can see that you cannot answer this question until unless you have knowledge of liquids and kinematics, that is projectile motion. If you remember the formula of range in projectile motion, then only you can answer a question like this. Only 2 responses so far, which only tells us that you have no idea of projectile motion. Only 2 answers. One, two, three, four. 4 answers. And answer is also 4 times. Only 4 responses. What is the value of range in projectile motion when you throw an object with speed u at some angle theta, this is range, and the formula of range is u square sine 2 theta divided by g. Product of a and v is constant. So if you make a by 2, then v should become what? V should become 2v. This v should become what? 2v. Then only you can keep the constant same. So if you are doubling the speed from u, if it becomes 2u, this is what? U square. So you can see that range is proportional to speed square. And therefore from r, it will become 4r. That's what you do. If you want to water a plant which is far away from you, you try to decrease what? Cross-sectional area. You're decreasing the cross-sectional area if by half, then the range, gain in the range is what? 4 times. So once you make it 2u, it is going to fall somewhere here, 4r. Now answer the second part of the question. What is the change in time of flight? Now I hope you can answer this part fast. All those who could not answer the range part, try to answer the second part. What will be the change in time? By what factor time is going to change? From this to this, what is the change in time? Good. The formula for time of flight is 2u sine theta divided by g. T is proportional to u, and therefore time will become what? 2t. The answer of this, let's see how many of you will answer this part. We are holding this pipe horizontally, and then if I halve the area, cross-sectional area, then what will be the change in r, range, and the time? I am holding the pipe horizontally at some height h. You are holding the pipe horizontally. In this case, once you decrease the area from a, you make it a by 2, then what is going to happen with range and time? Good, one person has answered correctly both parts. Now, unless you have the idea of range during horizontal projection, you cannot answer this. This shows the importance of all the previous chapters. For horizontal projection from height h, if you throw an object with speed u and it lands here, then I hope you remember that t was root over 2h by g. When you reduce your area from a, it becomes a by 2. Speed will definitely change, becomes 2u. But look at the time. This term of time has no u in it. शायद याद होगा horizontal projection में अपन ने इस तरह की चीजें की थी, that a bullet is fired horizontally and a stone is dropped. Which one will touch the ground first? Simultaneously. Remember, listen again. If you fire a bullet horizontally and you drop a stone at the same time, they both are going to hit the ground exactly at the same time. Because for horizontal projection, time is independent of u, and therefore for t your answer is what? It will remain same. What was the formula of range? U square sine 2 theta upon g. No, this is used only for ground to ground projection. This is horizontal projection. In horizontal projection, range is given by u times root over 2h by g. That means r this time is proportional to what? U. For ground to ground projection, r is proportional to u square. लेकिन इस बार अपना r किसके proportional आ रहा है? u. And therefore, from r, your range will become 2r. Note down everything. Write down Bernoulli's theorem. What is Bernoulli's theorem? Let's develop it just like continuity, and then in the end we'll write the statement. This time we'll draw a pipe like this. This cross section is A1, velocity is V1. This cross section is A2. This is A2, and velocity is V2. This is ground, or any horizontal level. From this horizontal level, you are saying that This height is h1. This cross section is small as compared to the height. Something like this. You have a pipe of this type, and this is the height. So you don't have to worry about height of this or this. So this is the height h1 of the A1 cross section, and height of A2 cross section is h2. And again, as usual, some liquid is present. But now, what is happening? We have to consider this. There is some liquid present behind, which is pushing this black portion, and the push is of P1 pressure. The liquid from behind is pushing this, and the pressure being exerted is what? P1. Liquid in front of this is going to push it back, and that pressure is P2. In Bernoulli, we try to relate P, V, and H. We'll be relating these three. How do we do that? Everything will be clear. Understand the setup now again. Cross section A1, speed is V1, pressure coming from the liquid behind is P1, and all the things at this cross section A2, V2, P2. This and this, because of P1 and P2, what happened? This liquid takes this new shape. Same thing, exactly same type of setup which we had in continuity theorem. Now, these molecules are common. We'll save time. All these molecules, water molecules, are same before and after, and therefore we can say that these molecules shown in red, 1, 2, 3, 4, 5, they appear at this position. Continuity में आपने समझ रखा है इस चीज को. If it is an incompressible liquid from black, if you make it blue, black and blue, whether liquid is compressible or incompressible, total number of molecules will be same. But if it is incompressible, then in common portion, number of molecules are not going to change because it's incompressible. If you could compress it, then number of molecules will increase in the compressed portion. It's incompressible, this doesn't change, and therefore we can say that कि किसी ने ये वाले red molecules को उठाकर यहाँ पर रख दिया. Which also means what? This common portion has no change in anything. Continuity theorem tells us that cross-sectional area multiplied by speed is a constant. At this cross-section, whatever is the speed before and after, they are what? Same. At this cross-section, same thing. At this cross-section, same thing. So in the common portion, during the entire process, no change takes place. We can say this. That means what? These red molecules, if you can see the color, these red ones, they suffer a change in their kinetic energy and potential energy. Red ones, they are moving with V1, and now we are saying that red ones are moving with V2. Red ones are at height h1, now they are at a height of h2. You are changing their potential energy. If you are changing kinetic energy and if you are changing potential energy, then some external work should be present. वो कहां से आएगा? What is P1? Pressure. ये किसने लगाया? पीछे वाले लिक्विड ने. कितना फोर्स दिया होगा? F1. What is force? Pressure multiplied by area. ये लिक्विड अपने आगे वाले को पुश कर रहा था, आगे वाले ने इसको पीछे पुश किया. With what force? F2. How much is that? P2 multiplied by A2. Pressure multiplied by cross-sectional area. F2 and F1, these are what? External forces acting on this liquid. तो अपने पास कहानी क्या बनी? ये था एक लिक्विड कॉलम जिसमें अपन इंटरेस्टेड हैं. इसके पीछे वाला पुश कर रहा है, ये अपने आगे वाले को पुश कर रहा है. ब्लैक ने इसको आगे पुश किया, रेड ने ब्लैक को आगे पुश किया. वी आर इंटरेस्टेड इन दिस. What we are going to say? We're going to say that the liquid from the behind is pushing it with a force of P1 multiplied by A1. Liquid in front of it is pushing it with a force of P2 multiplied by A2, and work energy tells us that work done by external forces is equal to delta K plus delta P. Now the requirement. For continuity, requirement was incompressibility. But for Bernoulli, if I am using this, then it means I do not want any type of loss. There should not be heat produced by the system. हमने भी डिस्कस नहीं किया है, but you all know about viscosity, which is friction. If we have a liquid which is non-viscous, which doesn't have any viscosity, in simple word, which doesn't have friction between its layers, then there will be no loss of energy in the form of heat, and I can use this. We'll write all these statements. For Bernoulli, we will be using two requirements: incompressibility as well as your liquid should not have any friction or viscosity in it. So, how do you answer this equation? We'll see that. Draw the figure and then we'll write everything. Draw this much. well, in case ये इस पोर्शन को मैं एक बार थोड़ा सा और इस तरह से एक्सप्लेन कर दे रहा हूँ, although hopefully चीजें क्लियर होंगी. When I say that this moves and occupies this position, in reality these molecules will be entering into this area. These ones, they are present over here, but since the common portion remains same, we are using the argument that somebody has raised these many molecules from this position to this position, which is equivalent to this. एक simple model के फॉर्म में यहाँ देख लेना भाई. 1 2 3 4 5. 1 2 3 4 5. Let's say these are the 5 molecules. And then what happened? You push this thing and they occupy this new position. अभी हमने हाइट चेंज नहीं करी है, सिंपल कॉन्सेप्ट समझने के लिए. दिस इज 1 2 3 4 5. तो बेसिकली हुआ क्या, ये वाला 1 यहां आ गया है, ये वाला 5 यहां आ गया है. अब सपोज जब आप इस पर्टिकुलर लेवल पर थे, तब लेट्स यूज काइनेटिक एनर्जी पार्ट ओनली, वही चीज पोटेंशियल के लिए वैलिड है. जब आप इस लेवल पर थे तब जो स्पीड थी वो थी से 20. जब आप यहां पर हैं स्पीड है 30, यहां है 40, यहां पर है 50, और जब आप यहां पर हैं तब है 60. I hope you can see the red color, all the values, and this is 10. The values in red, they are giving you what? Speed. तो ये जो 1 वाला एक इससे मूव कर रहा है 10 से, 220, 330, 440, 550, and once you arrive at this position, your speed becomes what? 60. देखा जाए तो क्या हो रहा है, 1 की स्पीड 10 से यहां पर, ये 1 यहां से यहां आ गया, इस जगह पर स्पीड क्या है? 20. तो एज सच अपन देखें तो क्या हो रहा है, 1 की स्पीड 10 से क्या हो गई है? 20. सिमिलरली 2 20 से क्या हो गया? 30. 30 से क्या हो गया? 40. 40 से क्या हो गया? 50. या तो हर मॉलिक्यूल की स्पीड के चेंज को एडजस्ट करो. कौन इतना टाइम बर्बाद करेगा. अपन ने क्या बोला? अपन ने बोला कि भैया ये जो पोर्शन है तुम्हारा, this portion is common before and after t0 at time t. फायदा क्या हुआ? उन्होंने बोला ये जो मॉलिक्यूल था, इस जगह पर जो भी मॉलिक्यूल्स हैं वो अभी भी किससे मूव कर रहे हैं? 20, 30, 40, 50. तो क्या मान के चलो कि किसी ने इस 1 को यहां से 10 से उठाकर यहां रख दिया, and it is moving with what? 60. In reality 1 10 से कहां पहुंचा है? 20 पर. तो फिर तो सबको काउंट करो. उससे अच्छा अपन ने क्या बोल दिया कि इस 1 का चेंज यहां से सीधे यहां ट्रांसफर कर दो. If you understand this, then write down yes in the comment box and continue with the derivation. And you can also draw this thing as a side note. In red, you're looking at the speed part. The black ones is the old numbering. This is the new numbering, and they occupy this new position. Now, वो सारी चीजें अभी भी वैलिड हैं. Well, you can always write A, B, C, D A dash B dash C dash and this D dash. Exactly the same thing. This distance is what? V1t. This distance V2t. सेम चीज. अब हमने क्या बोलना शुरू किया? हमने बोलना शुरू किया, लेट्स से मास ऑफ दिस पोर्शन इज m in red. Mass of this portion is also what? M. So we can say what mass of A dash D dash D. A dash D dash D is what? M, which is same as mass of B dash C dash C. B dash C dash C. कोई टफ चीज नहीं है, वही जो भी थोड़ी देर पहले किया था वही सब दिख रहा है. इस पोर्शन के जो मास है इसको अपन ने क्या बोल दिया है? M. And this is also what? M. Now work. What is work? Force dot displacement. If it is force dot displacement, then what is the force? What is displacement? And dot means what? Cos 0. Let's find the whole thing. Force. I'm directly using force. If you wish, you can write F1 dot S1. Or let me do the same. F dot S, in case you get confused, plus F dot S, which is equal to what? Delta Ke. What is delta Ke? Half M V2 square minus half M V1 square. This cross section is A1. And speed at this cross section is what? V1. Force dot displacement, change in kinetic energy. This M initially is moving with V1 and finally is moving with V2. Change in kinetic. इसी के आगे ऐड कर देना भाई. Plus delta P. What is delta P? mgh2 minus mgh1. Work done by external force F1, work done by external force F2 is what? Change in kinetic energy plus change in potential energy. Note down this fast so that I can erase some portion and we can write the equations in a proper manner. Note down this much fast. Now look here. What is F1? P1 into A1. Multiplied by displacement. What is displacement? V1 into T. Multiplied by cos of 0. Plus F2 A2 P2. Displacement V2 T into cos of dot means angle between force. What is force? Normal reaction force towards the body. But displacement is this way. This cross section is moving this way. It is under a force which is pushing it back. And therefore, what is the angle? 180. That's your left hand side. On the right hand side now, you've got what? Half mv2 square minus half mv1 square plus mgh2 minus mgh1. So this is your take m common, and you can write it v2 square minus v1 square by 2 m out 2 plus m out g h2 minus h1. This is this. Now let's find this mass and use it for our equation. It'll take 2-3 minutes more. What was mass of A dash D dash this? What is mass? Volume into density. Let's use that. So your M is V1 T A1 rho. Continuity theorem. What is mass of this portion? V1T cross sectional area multiplied by density. And mass of B dash C. Mass of this is what? Volume into cross sectional area into rho, which is nothing but continuity theorem. फायदा क्या हुआ ये इक्वेशन इस तरह से फॉर्म करने का? Look at this number A1 V1T. What is A1 V1T? M by rho. A1 V1T. A1 V1T is M upon rho. This plus this cos 180 minus 1 minus P2 A2 V2T. A2 V2T. What is A2 V2T? Rho M upon rho. M divided by rho. And on the right side you already have what? M times the whole thing. ये सब भर देना इसके अंदर. You can do that. You are saving time. All this M cancelled. M cancelled. And now I'm removing this figure. once you cancel m, we are also multiplying the whole thing with rho. If you multiply the whole thing with rho, what do you get? You get this P1 minus P2 multiply by rho. M got cancelled, multiply this thing with rho, you get half rho V2 square minus half rho V1 square. You are multiplying this equation with rho. Multiply these things with rho. Plus rho G H2 minus rho G H1. Rho G H2, rho G H1. Take all the terms of 1 to the left, 2 to the right, and you get P1 plus half rho V1 square. This minus to the left, plus rho G H1 is equal to P2 plus half rho V2 square plus rho G H2. This is Bernoulli's principal theorem statement. What is the statement? Sum of pressure half rho V1 square and rho G H1. Some of these three things, which are called pressure head, HEAD, kinetic head, potential head, for an incompressible non-viscous liquid is everywhere constant. That is P plus half rho V square plus rho GH is a constant. We'll write a statement, but if you understand this derivation, I mean, you know that you understand. You cannot directly reproduce everything if I ask you to do that right now. But if you understand everything, then write down yes in the comment box and then we'll write a few statements. Write down the statement. According to Bernoulli's principle or theorem, we call it Bernoulli's principle also. According to Bernoulli's principle, sum of pressure head HEAD, kinetic head and potential head for an incompressible non-viscous liquid is a constant. Inside the bracket, next line, inside the bracket, non-viscosity means non-viscous liquid means there is no loss in the form of heat. There is no loss in the form of heat. And incompressibility means we can use continuity theorem. And incompressibility means we can use continuity theorem. Just write down an important line, separate important line. जो अपना continuity theorem था, basically वहां पर आप क्या कर रहे थे? मास कंजर्व कर रहे थे. That is based on conservation of mass. And this Bernoulli is based on conservation of energy. You're conserving energy, some energy is coming and you're trying to conserve that. Write down this. Continuity theorem works on the principle of conservation of mass, definitely for an incompressible liquid. And Bernoulli works on the principle of conservation of energy. This kinetic head term is not something which is confusing. This is half mv square. This was what? Kinetic energy. If you divide kinetic energy with what? Volume. What is mass upon volume? Density. So the term which is called kinetic head is nothing but kinetic energy per unit volume. Similarly, this potential energy part, what is potential energy? mgh. If you divide this thing by V, volume, m upon V is what? Rho. So kinetic energy per unit volume is nothing but kinetic head. Write down this also as a side note. Kinetic energy per unit volume is kinetic head, and potential energy per unit volume is potential head. In the next class, we'll solve a few examples on this Bernoulli and all. Write down this much and then you can leave. Thank you very much.